This video is more for beginners, and you might know all this, or maybe you'll know some of it. My overall goal is to democratize and teach AI to everybody. If you know someone that's struggling to get into AI, share this video with them. And stick around because maybe you'll learn something. Welcome back to the series on the introduction to AI terminology. In the last video, we started with the basics and looked at the big picture. We went over some of the most common terms. If you haven't seen that video yet, I'll put a link to that somewhere on the screen. I definitely recommend starting there. Now today, I want to dive a bit deeper into how some of these systems work, especially large language models. Let's talk about one of its foundations, machine learning. Machine learning, or ML, is a type of AI where computer systems learn from data to get better at a specific task over time, all without the need of having someone write a new line of code for every new situation. Think of it like this. Instead of giving a child a rule book for identifying cats, you just show them lots of pictures of cats. Eventually, they learn how to identify cats on their own. Many of the AI features we use daily are powered by machine learning. A very powerful subset of machine learning is deep learning. Deep learning uses structures called neural networks, which are kind of inspired by our brains. These networks have many layers of neurons or nodes that process information. This layered structure allows them to learn really complex patterns from huge amounts of data, which is what makes things like image recognition possible. So when these neural networks are learning, what are they actually doing? Imagine the AI is trying to tune a very large, complex radio, like a big soundboard. To get the clearest signal, you got to turn a lot of different knobs. And these knobs are actually known as parameters. In AI models, parameters are the internal settings that the model tweaks and learns during its training. And we're talking about millions or even billions of these tiny little dials. And if you remember from the first video when we talked about AI models coming in different shapes and sizes, what we were really talking about is how many parameters they have. The more parameters often means a bigger, more capable model. And once a model has finished its training, all those parameters, those knobs, get set in stone to specific values. These are often referred to as the model weights. And the model weights are basically the knowledge the model learned during the training. And they determine how it will respond when it sees new information or tutor prompts. You could kind of think of the weights as the AI's memory, or its experience, but it's all stored in numbers.
Everything's computer.
Now that we spoke about the training of the model, which is usually on large amounts of data and very broad, what if we want an AI to be really good at something specific, like writing medical reports, or to have it behave in a very particular way? That's where fine-tuning comes in. It's like taking that generally smart AI and sending it to a specialist school. Essentially, you're training it a bit more, but this time on a smaller, more focused data set to make it an expert in a particular area or to adopt a certain style. And a really powerful way to fine-tune, especially for making chatbots better, is reinforcement learning. And some would say reinforcement learning is all you need. So what is reinforcement learning? It's just like it sounds. Imagine you're training a dog. If it does the trick correctly, you give it a treat. If not, you don't. Reinforcement learning is very similar. We rate the AI's responses, giving it a score for good answers and a bad score for worse ones. And basically, over time, the AI learns how to produce better responses. So we know that models can sometimes be out of date or even make things up. We talked about hallucinations in the last video. This is where RAG comes in. RAG stands for Retrieval Augmented Generation. If a pre-trained model is already pretty smart, you don't necessarily need to retrain it. You might just want to have it access your specific up-to-date information, like your company's latest documents, or recent news, or your personal notes. RAG makes this possible, and it's often a lot easier and a lot cheaper than fine-tuning. So this is how it works. You're talking to an AI, you ask it a question. That question is very specific. Most likely, the AI is not trained on that data. So it does a quick search in a specific trusted knowledge base that you provided. And this could be your company's internal wiki, a database of recent articles, or your personal notes, anything you provided. It retrieves the most relevant information or embeddings, then it uses that information to augment or enhance its answer. This makes the responses more accurate, current, and based on actual facts, therefore cutting down hallucinations. RAG is not only cheaper and easier than fine-tuning, it's improving all the time. But for RAG and other advanced AI functions to work well with text, the AI needs a way to truly understand the meaning behind the words. In the last video, we talked about tokens. But how does an AI actually understand the meaning? And that's where embeddings come in. Embeddings are a way of turning words, sentences, or even whole documents into a list of numbers, like a numerical fingerprint. Think of it as a giant map, like a 3D multi-dimensional map, where words with similar meanings are placed close to each other. So king, queen, and prince would be neighbors on the map, and apple, banana, and orange would be in a different neighborhood altogether. And this map of numerical representations allows the AI to grasp context, to understand the similarity, and see the relationships between the different pieces of text. It was actually a core part of how LLMs make sense of language. Okay, so I think we're going to cut it there for this video. We went over a lot of larger, more in-depth topics today that I think are crucial for understanding the next, even more advanced concepts that we'll cover in the next video. And in the next video, we'll be diving into more exciting topics like reasoning models, AI agents, workflows, and how AI performance is measured with benchmarks. So if you found this video helpful, please give it a like. If you haven't done so already, subscribe to the channel. I'm trying to differentiate and democratize my content, not just from advanced tutorials, but to more basic understanding of AI, because I believe that everybody should understand what's going on. Feel free to share this video with anyone you think that would find it useful. And if there are any other AI terms you're curious about or anything that wasn't clear, drop it in the comments below. Thank you guys for watching and have a great day.